All right, we've made it to a rather legendary section in Algebra 1. This is the quadratic formula section, one of the most famous formulas in math, one that you can talk about with people in college because they will have all definitely had it and remember something about it, either loving it or hating it. Here's your essential question. How can I find solutions if I don't factor them, if they don't factor properly, and if I can't use the square roots method? If I can't use either of those methods, and I don't want to look on my calculator, how can I find them? Well, as it turns out, there is a quadratic formula. It's this big, long one, and there are many plethora of memes. This is the one I settled on because it's just a really complicated formula. So let me explain. First of all, just to remind you of other methods, what we really like to do is we really like to factor these. So if we have something like 0 equals x squared minus 3x minus 4, this we can factor, and then it's easy to solve. Or if we don't have a b term, we can use square roots. So if I have something like x squared minus 16, I can move the 16 over, I can take the square root, I cannot forget about the plus or minus. But what happens if neither of those work? So, quadratic formula. Here's the deal. This works always, whether I can factor or not. What it relies on is this. You must put your quadratic into the standard form, okay? So I'm solving for the zeros, so I have equals 0, and then I have it in standard form, ax squared plus bx plus c, just like when we were graphing. What you're going to do is you're going to take each of these letters, the coefficients of x squared, x, and the constant term, and you're going to plug them into this big, long formula. Yes, you do need to memorize this formula. There are songs that help you memorize it. I may post the link to one along with this video because it's just easier to memorize the song. I'm not going to sing for you because I am not Harry Styles or someone else who's a pop star who I can make fun of. Okay, so here's the deal. Here is a quadratic equation. Now, let's see if we can factor this, because if we can factor it, then that would be better. I definitely can't use square roots because I have a b term. So let's try to factor over here. I'll do it over here. So we're going to get a 0. So 3x squared plus 5x. If I subtract 8 from both sides, now I have a 0. Now I think this actually does factor. And remember, because of this 3, it uses the more complicated factoring. I need to use 3x and x. Now let's see, there are a couple different ways of multiplying to 8. There's 2 and 4, 8 and 1. I think if I put the plus... this is actually a pretty tricky one. I think if I put the plus 8 here and the minus 1 here, that should do it. Because I have 8x, yeah, and then minus 3x. So that adds up to 5x in the middle. Okay, so anyway, I can factor this one. X would be negative 8 over 3. X would equal 1. I'll let you, if you don't know what I'm talking about, go back and watch previous videos. But anyway, this one does factor, and these should be my answer. But what if you hadn't seen this factoring? This is not the most obvious factoring. Well, let's use the quadratic formula. And if I do it right, I should get the same answer. So here's your introduction. First of all, just like when I factor, I need to have it in standard form with a 0. So I'm still going to move that 8 to the other side. Now I have equals 0. If I don't have equals 0, no quadratic formula. So you need to get the equals 0. Okay, now, I need to figure out what A, B, and C are. And I need to plug those into the formula. So, let me write the formula out. I'm going to be solving for x. So the formula is x equals. And it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's start putting letters in. I know that b is 5, so this negative b becomes negative 5. Here's another b, so instead of b, I'll put 5. Okay, now I have an a, so instead of a, I'll put 3. Let's put this 5 in parentheses, it's good practice, because what if it was negative? The c, this is negative, so, whoops, I can't erase anymore. So for c, I'll put negative 8, and on the bottom, I have an a. So 3. All right. Now, this is a really long problem, and it's complicated. First of all, we need to worry about the plus or minus. Just like in square root problems, plus or minus indicates that there are two different solutions, one which involves the plus and one which involves the minus. But in order to figure out what I'm adding or subtracting, I need to figure out what this square root is. Now, order of operations says I need to do parentheses first. And if you can imagine it, inside this square root is kind of like a parenthesis. So the first thing that I should do is I should simplify everything in this square root. And I'm literally just going to put into my calculator 5 squared minus 4 times 3 times negative 8. Because if I put that all into my calculator, it should do it for me nicely. Okay, so I just typed it into my calculator, and I found that all of this equaled 121. So under the square root is 121. I can also simplify the bottom. 2 times 3 is 6. Okay, so the question is, what's next? I'll move down to this line. Let's actually take the square root of 121, and conveniently, 121 is a perfect square. That happens to be 11. So the square root of 121 is 11. Now, order of operations says next, I need to think about the top and figure out what the top is. But because of the plus or minus, one of the tops is going to be negative 5 plus 11. So let me write that. Here's where I'm splitting into two different answers. And one of the tops is going to be negative 5 minus 11. And these are two separate answers because remember, when we're solving quadratics, since the quadratic often crosses twice, there are two separate answers. Okay, so I just need to figure out what they are. On top here, negative 5 plus 11 is 6. I have 6 over 6, which is 1. On the bottom, negative 5 minus 11 is negative 16. So negative 16 over 6, I think that reduces to negative 8 over 3. And would you look at that? That is the exact same two answers I got when I factored. So quadratic formula, pretty neat, pretty useful. It always works. We just need to get used to how to plug things into the equation and how to simplify because it's a little bit complex. So let's take a look at this next problem. First of all, whether I'm factoring or using the quadratic formula, I need to get a 0. So subtract x, subtract x. Let's just make sure to write it in standard form, so put the x in between the 2x squared and the negative 7 so that my exponents are in order. Here I've canceled, and so I have the 0. Now, I don't think this factors, and the reason I don't think it factors is because 7, only 1 times 7, 2, only 2 times 1. I don't think I'm going to be able to get those to combine to a negative 1 in the middle. So I'm not able to factor this, so let's go straight to the quadratic formula. So remember, identify your a. B here would be negative 1, and then C would be negative 7, and I'm plugging into the formula x equals negative b plus or minus square root b squared minus 4ac all over 2a. And yes, I've committed this to memory. I know that I'm the teacher, but the point is you need to commit it to memory as well. So let's start plugging in. I have a b, which is negative 1, so I have kind of a double negative thing. Here's another b, still negative 1. And remember, I'll put it in parentheses because when I square negative 1, I should get positive 1. If you just put this into your calculator, it'll give you negative 1, which is wrong. So put it in parentheses. Big deal. A is 2, C is negative 7. So again, just plugging into the formula. Okay, here's one more A. That's 2. All right, so let's simplify some things. First of all, this double negative cancels. It's just 1 plus or minus the square root. Remember, I can do all this under the square root in my calculator. So let me plug it in. Okay, and my calculator is giving me 57. On the bottom, 2 times 2 is 4. Unfortunately, this 57 is not a perfect square. So when I take the square root, I am getting a decimal. So 1 plus or minus 7. I'll round to 2 decimals here. And this is all divided by 4. All right, so here's where now I need to start simplifying the top. Here's where I need to split into two separate fractions. One with the positive and 1 with the negative, 1 minus 7.55. Remember, that's what the plus or minus means, because I'm getting two separate answers. Now, if you're clever, you can put this all into your calculator in one step. Just make sure, if you do so, to put parentheses on the top. If you just type in 1 plus 7.55 divided by 4, your calculator thinks you're doing this problem, which is much different than the one being on top with the 7.55. If you put parentheses around, it avoids that issue. So let me put these into my calculator and see what I get. For this one, I got 2.1, we'll round to 1.4. For this one, I got, let's see, negative 6, oops. La-di-da, stalling for time while I type into my calculator. All right, I got negative 1.64. So here's an answer, two separate answers. So the quadratic formula, yes, it's a plug and chug problem, so it should be straightforward, but you have to be good at the flow of it, splitting it up, calculating what's under the square root, all that stuff. You need to use very good order of operations. All right, so summary. As long as you get a 0, you can use that big old formula, which you should have memorized. Remember that, yes, you do need to memorize this. So check out that other video I'm linking to your announcement. It'll be some nerdy math teacher singing the song repeated a couple times to help you memorize it. Thanks for watching.